and welcome to another episode of FooBar. In today's episode, we are going to talk with Ben Smith, developer advocate for AWS and one of the most experienced persons about step functions. So he has been working and he has been creating a lot of the patterns that we know about step functions, and a lot of the things that you have seen around about step functions come from his brain. So I'm so excited to have Ben here. In this interview, Ben is going to share with us everything related to cost analysis when working with step functions. So let's get to the interview. Hello, Ben. How are you?
I'm super, thanks. How are you doing, Marcia?
I'm so excited after reInvent and now being back, all the step functions announcements, and now we continue talking about step functions because they're cool.
No, it's mad, isn't it? It's like it feels like just literally yesterday. And, straight into it again.
Indeed. But I don't know. I have to say that my love for step functions came from you. So I'm super happy to have you here. I enjoyed step functions before, but I never saw the power of it until I started watching all the content that you put through and how you say step functions always, or what is the motto?
Always, yeah. It's definitely my favorite topic to talk about at AWS, yeah.
So I'm very excited that you're here today. So maybe you can tell a little bit to the audience who you are. I'm pretty sure everybody knows you, but just in case somebody doesn't.
Sure. So I'm Ben Smith. I'm a principal developer advocate for the serverless product space on the same team as Marcia, and I'm based out of our London office.
Nice. And you're our step functions guru.
Yeah, somehow. So I've been working with step functions predominantly since joining AWS about 4 and a bit years ago. And I've just kind of been drawn to it because of the simplicity, really, of building with step functions. So just by way of working with it more than any other service, I've sort of found myself talking about step functions more than anything else, I think.
Yeah. And you're a developer, so that's your background. You've been coding always, and you love to solve problems and build applications.
Yeah, I like that, actually. Problem solver is probably a better way of describing what I have done before joining AWS. But that's right. I was a web developer for about, 15, 16 years, initially with PHP and then moving on to Node.js.
Yeah, and in our team, you have built Serverless Espresso, Serverless Video, that if people don't know about it, are like 50% step functions or more.
Yeah, exactly. I think that's why they're mostly step functions, right? Because it was, I was a big part of the build for both of those things. So it seemed like a natural draw to go straight to step functions for both Serverless Espresso and Serverless Video.
When you realized that step functions was this tool for building applications?
Well, before joining AWS, I worked for a company called Automic, which was an Austrian software company that specialized in workflow automation. And they were later bought by CA Technologies, who were later bought by Broadcom. But all the way through all of those acquisitions, they kept this really powerful orchestrator tool, which was a way of building workflows for mostly on-prem systems. But that was the first time I really started to understand the power of building things with automation workflows. So coming to AWS, what was different about step functions was that it was workflows as code, as JSON syntax, essentially, rather than a drag and drop interface, because we didn't have that at the time, right? We didn't have Workflow Studio then. But I thought that was really interesting because you could then create workflows to orchestrate all of these various serverless components, and you could commit those workflows to your GitHub repositories, move it in amongst your infrastructure as code templates and share it with your development teams. And when I started to understand that it wasn't just something that you build in the console, it was something you can actually run and share as code, then it became something much more useful. But the reason I think step functions is in many ways the answer to building on AWS is because when you're building out applications that are relying on essentially cloud services, right, managed services for very sometimes quite bespoke things that it needs to do, things like Lambda functions for compute, DynamoDB for data storage, all these different services that you're using that are managed, you need a way to connect the data that moves between these services, whether that's using events or APIs or messages. And I think this is a big challenge, right? Is understanding how your application's held together when it's just consists of lots of managed services that are running in the cloud. So an
Yeah, and I think
orchestrator,
many customers use Lambda for that, because that's kind of the natural thing as a developer to
yes,
build code. Oh, I know JavaScript. I will just call the AWS SDK. I will call Dynamo, and then I will call this other service, and then I will put things in here, and I put things in S3, and I do this processing. So the mixture of business logic and API calls and building this kind of Lambda that orchestrates everything.
sure. And that makes sense, right? Because as a developer, you go straight to the code, and pretty much every getting started guide you'll find on AWS about serverless will start with Lambda, because Lambda's brilliant. But Lambda's brilliant for compute, and the billing model is based on using Lambda for compute, right? Not for stringing other services together necessarily, although it's been good at filling that gap for a long time. But when you have service like step functions, that's purpose is to orchestrate all of those other services, and it seems obvious once you get to a certain point of understanding what step functions can do, that you would use an orchestrator to understand how to move data and how to invoke those different services rather than do that as code, right?
Yeah, I think that's a question. I think some of my customers might hate me when they tell me, I would love to learn how to do integration tests with Lambda. And it's like, why you don't move to step functions? It's like so simple. You do all your integration there. You have your unit tests for your Lambda functions because they are doing business logic, so it should be easy to. And they're like, why? Well, you get the params, the console log with the params in the beginning of running the state. You get the response console log. Everybody does that when they are doing tests and like starting to explore different integrations, and step functions bring that for free.
Yeah, I mean, when you have your application that's spread over multiple Lambda functions normally, and having to track and inspect how the data passes through each one of those functions, it's really difficult, actually. Like, it's a problem. And with step functions, that's naturally the thing that it's solving, right? You can see every execution, you can drill down into every execution and see exactly at which point your workflow took, which route it took or where it failed. And you can even drill down into each step and see what the data looked like before it entered the step and what it looked like when it passed out of the step. And if you don't use an orchestrator or some other tool, then you're kind of chasing around different CloudWatch logs trying to find that same information. So it really gives you a central point, not just to build, but to inspect and understand how your application is held together, or at least how different microservices within your application are held together, right?
Yeah, and well, Visual Studio, the Workflow Studio is great because then you can open these state machines that you wrote like 3 years ago, and you can visualize it and see how the things flow, and you can inspect everything in there and see all the execution. So if you forgot what you wrote, that it happens always to me. It's like, oh, and then if you are writing code, you need to read every bit of code to know what exactly happened. So
yeah, I have a nice example in one of my talks actually, where I walk you through retrieving a record from a DynamoDB table using Lambda, right? So this is not doing any kind of computation. It's just getting an item from DynamoDB. And even in doing this in a very simple way, it would take about 20 lines of code to get an item from a DynamoDB table when you already know the partition key, right? To do it with a step functions workflow, it's as simple as dragging in the get item action. And I think that little demonstration, 20 lines of code and a few minutes to write that out versus, 2 seconds to drag in the get item and you're done. I think that really helps hit home with people why you might use one over the other. Sometimes, in some instances, right?
Yeah, sure. Lambda is not to replace, but it has to have its right purpose. As I always say, for that business logic, that is very specific for you, for all those like calculations and processing of data that you cannot do with any other any other service. Lambda is awesome, serverless compute.
Exactly. Yeah, and which step functions is not, right? It's not a compute engine at all. It's an orchestration
Well,
engine.
it kind of does a lot of compute. Sometimes is because we will see today we are going to talk about costs, and I think the billing model, well, it's running on compute at the end of the day, but it's a different type of compute.
We don't care where it's running. It's just
exactly.
running.
It's
It's
just
serverless.
running.
Yeah.
Exactly. So, as I said, we are going to talk about costs in this video and cost analysis and understanding is a step functions expensive? Because that's at least one question I hear from some customers. I don't like it. It's expensive. And I was like,
Yeah.
I don't know. Maybe you're not doing it right, or maybe your use case is very special. But I think it's good to chat a little bit about that. Have you heard that?
Yeah, this is a objection I've heard a lot over the years, and I think it's true. You can say something like this of any AWS service, is that once you start to understand the different features and functions that are there to help you and really know what's available to you, you can use all sorts of ways to reduce that cost and optimize, and often reduce the duration of your applications running as well, right? Especially with serverless applications. Normally, if you can make it faster, you can also make it more cost effective too. So I think the Step Functions team has done some brilliant work in the last 3 or 4 years to giving you ways of cutting down costs quite significantly. Well, the first thing I would bring people's attentions to when they're looking at the cost of step functions is to have a look at the difference between a standard and an express workflow, right? So express workflows were brought in 2019, I think, at reInvent as a new mode that you can run your step functions workflows in. And to understand the difference between the two will really help you. And I think this is quite low-hanging fruit for people to instantly go away and evaluate. So the key difference, I'll go through it a little bit here, is that standard workflows are longer lasting, okay? So they can run for up to 1 year. They're asynchronous, so if you invoke a standard workflow, you have to request it by some means to get the result, okay? Because you can't have a service wait for a year to send you back the result. And they're exactly once execution model, so you won't get any duplicate invocations with the same payload with the standard workflow. Express workflows, they have a much higher throughput, so they transition through states much faster. They have a totally different billing model, which I'll show you in just a moment. They have this at least once execution model, so there is a chance you'll get duplicate invocations with the same payload. So what you'll have to do is make sure the steps in your express workflows are idempotent. So if you run it with the same input, you always get the same result. Another key thing with express workflows is that they can run asynchronously and synchronously. So you can invoke an express workflow and have that service that invoked it hang around and wait for the response. And the reason that they can do that is because they have a max duration of 5 minutes. So standard workflows can run for 1 year, express workflows can run for 5 minutes. But they both have different billing models, and that's the crucial thing to understand, I think, as we go through this next piece.
Yeah, I think express workflows are one good example on this kind of customer obsession, because I think when the step functions team builds step functions, they thought about the standards, the long-lasting process, and then people start, we can do really interesting things here with serverless, and start building very short things to solve very specific things in their APIs and in the backends, and like you do all the time. And the standards were kind of expensive and slower. And they was like, what if we make it faster? And then they launched Express. And I think it really solved a lot of people's pain points.
Yeah, I mean, I would love to know what the percentage is of customers' workflows that take less than 5 minutes to complete. I'm sure it's more than 50%, right? I'm sure there's loads of little workflows out there that are fast and quick and spin up and down, in response to events, where people could run that as an express workflow, where maybe they've just chosen the default standard workflow mode. I've got a nice little example here. So this is a step functions workflow that imitates a shopping cart checkout system, right? So it does some standard things like approve an order request, and then it waits and it polls a DynamoDB table to check that the order's ready to be processed. And then it puts a message onto an SNS queue, and then it polls another DynamoDB table to check that payment's been taken before running some idempotent Lambda functions to update inventory and customer profiles and stuff like that. So what I did is I ran this 1,000 times as an express workflow with some simulated input payloads, and then 1,000 times as a standard workflow with those same inputs, just to have a look at the results and see what the cost was of those two different modes, right? And I think it's quite interesting. So the standard workflow, when run 1,000 times, costs 42 cents for those 1,000 execution, whereas the express workflow costs 1 cent. Now, it's exactly the same workflow definition, producing exactly the same results. And in fact, the express workflow completed about half a second quicker on average. That takes about 11 seconds for the whole workload to run.
Yeah, that's something, as you said, pretty easy to switch, because you can basically switch from standard to express if there is some limitations of what express can do. But if your standard workflows are not applying those patterns or things like that, then you can basically switch it and boom, you can save this much. And this is on 1,000 invocations, but what happens if you have, I don't know, millions of invocations?
Well, good question. We have that here, but I was going to walk you through why it costs that, because I don't think we've mentioned how the two are actually billed.
Yeah.
So with your standard workflow, it's all about the number of state transitions that you have in your workflow. So a state transition is when the data pass from one step to the next or one state to the next. And with standard workflows, it costs you 2.5 cents for every 1,000 state transitions, right? So what you do is you take a workflow like this one I have here, you figure out the happy path, right? This is the path that my data will take most of the time. There's 17 state transitions there. I'm going to run this 1,000 times. So I do 17 times 0.025, and that's how I get my 42 cents. Now, there is an asterisk there because there is a free tier for standard workflows, but so we can compare like for like, let's assume we've gone past that already, right? So that's how you get the cost of your standard workflow. For Express, it's entirely different. It's not really got anything to do with the number of state transitions, although that, I suppose, that indirectly affects the cost. But what it's about is the duration of your workflow. How long does your workflow need to complete to the nearest 100 milliseconds? But there's also another part of that, which is how much memory does step function service need in order to run your workflow. And that's based on things like the size of the input payload and the size of the workflow definition. And it goes up in 64 megabyte increments. So this is a table taken from...
So these are kind of the same parameters as we have with Lambda, like duration and memory allocation.
Yes, exactly. Yeah. Although I think the difference is with Lambda, you can configure that yourself, right?
Yes.
You can set that in your function.
But this is even more serverless.
Yeah. I think with step functions, they just figure out what's the minimum that you need. And this is the cost. So this little workflow that I have has only got, 17 state transitions. So the price per 100 milliseconds for the first 1,000 GB hours is this tiny number here, right? So when I put that back into my calculation and I put the duration, which is 11.3 seconds, and I times that by 1,000, that's how I get my $0.01 or 1 cent. And you asked earlier, what if I was to run this 1,000,000 times? Well, here's the result. Yeah, they start to move apart really quickly, right? My express workflow is about $12. My standard workflow goes into like the 400 mark. And again, it's exactly the same workflow definition. I'm just choosing to run it in a different mode.
And this is when customers might say that step functions is expensive, but then it's so simple sometimes to just make it extremely cheap.
Yeah, it can be. It can be. So the first question that you should ask, right, is why would I ever bother using a standard workflow? And there are, of course, times when you will. That's if your workflow does take more than 5 minutes. then you've got to use a standard workflow, right? Or if you need that exactly once execution mode, or if you need this wait for task token or sync patterns, which we can talk about after. These are things that only are available as a standard workflow. But there's things you can do even if that's the case, right? So even if you need to run your workflow as a standard, you can use both. You can embed an express workflow inside your standard workflow. And this is a really interesting pattern to optimize both the speed and the cost of your workflows.
Exactly, because sometimes you might have some pieces that are just processing things like you're calling Lambda function and Dynamo and things like that you might not need to wait, and it can be done very fast, and it's a lot of transitions. You just nest them together and package it up.
Yeah, it's exactly that, right? So in this example, let's say that this polling loop here, let's say that does take more than 5 minutes. Maybe there's a person involved, or maybe that's some asynchronous thing we don't have control of. So that's exactly as you say, right? The first thing I would do is that now we have to run this as a standard workflow. The easy thing here would be to just strip out those idempotent Lambda functions that are just doing very simple things, save them as a separate express workflow, and then call them synchronously from my parent standard workflow. So the parent workflow can wait for them to complete. They'll complete very quickly because they're just some simple Lambda functions. But because that's running as an express workflow, we don't mind how many state transitions there are. And I've actually put that back into the cost here, right? So you want to work out the cost now, you just add them together. So my standard workflow, which is based on the number of state transitions, remember, I've lost a whole bunch now. It's just 14 state transitions. So now that just cost me 30 cents to run it 1,000 times. And my express workflow, well, that finishes in just over a second. So that the cost of that is almost insignificant, really. Yeah. So now, simply by extracting some of those steps out and saving it as a nested express workflow, I've knocked off 12 cents per 1,000 executions.
That in a million is starting to
yes, exactly.
appear.
Exactly. Yeah, pennies add up, right?
Exactly.
So that's like the first low-hanging fruit I would always suggest for people to go away and look at is, can you run some or part of your workflows as an express workflow, and then have a look into that first.
Yeah, so changing either the whole workflow or partially, and maybe you can start seeing the results. Can you see these from CloudWatch dashboards, or how you get the pricing and the memory allocation and all those things?
Yep, you can get that from CloudWatch, exactly. Yeah, I think you can even get the memory allocation from each individual execution. So from the executions page, I believe it says it there as well. But CloudWatch is always the place to go, isn't it, if you want detailed information.
So then people can go and check it out there.
Yeah. The key thing, really, the key takeaway for costing your workflows is with standard workflows, you've got to reduce the number of state transitions. Express workflows, you have to make it finish as quickly as possible with the smallest payload you can use. So you've got to manage that payload as it passes through to reduce the memory allocation that's needed.
Yeah. So you were mentioning before that there is this loop, and we can replace that somehow in order to remove more transitions. How we can do that?
Yeah, so I can talk about that. So this polling loop, this is an asynchronous thing, asynchronous operation that's happening. And what people often do is they poll for the result of this asynchronous operation, right? Because we're used to polling. It's really easy to implement. I often tell a story when I'm talking about asynchronous and polling about going on a trip with my daughter earlier on in the year to France. So we live on the south coast of England in a little city called Brighton. And earlier in the year, me and my 7-year-old daughter, we took a trip to France. And when we got on the boat, the first thing she started asking me was, how long is the boat going to take? And I looked it up, it was 5 hours. So we're sat on this boat for 5 hours, and my daughter, every 10 to 15 minutes, she's checking me, Dad, are we nearly there yet? Are we nearly there?
I'm pretty sure you're not the only one that suffers from a polling child.
Exactly, yeah. This like constant loop of like question, wait, check, question, wait, check. We're going around this thing. And, it's really annoying for the trip, but also linking that back to your workflow, right? It's really expensive because every time you go around this loop, that's 3 more state transitions. And you could maybe wait longer, so there's less state transitions per execution. But like if that was me and my daughter, that would mean we could wait, we could be sitting at the port for an hour before she asks me and we get off the boat, right? So it's the same with your workflow. If you crank up the wait time, you won't get a timely response. And if you crank it down, it's going to cost you more and more money. So the pattern to solve this is this callback pattern or callback concept, where this would be me and my daughter getting on the boat and her saying, "Dad, can you just let me know when we get there?" And then when we get to France, I'd be like, "Right, we can get off the boat now." And you can do that with step functions too.
But you cannot do that with daughters.
You can't do that with daughters, no. You've got to give them something.
It would be amazing. We can do that with kids, but I don't think that will happen ever.
Yeah, just sit in silence for 5 hours, yeah.
Lucky you.
So this pattern, the way you do it in step functions is to use this emit and wait pattern. And with everything I build in step functions, I either use one or both of these 2 really powerful patterns. And this is the first one, right? This is the emit and wait. And for this, I often end up using Event Bridge along with step functions. They go really well together. It's like Batman and Robin or something, that they're just partners, right? And what we do here is we can orchestrate a series of milestone events. So anything where you have like a conveyor belt of things that you need to happen in a certain order, or you can shrink it down and say anything where you would poll for a result, but instead of polling, you want a callback. That's where you should straight away think, can I use this emit and wait pattern?
Yeah, I always say that this is good for this asynchronous integration, either to a service that inside AWS, like, I don't know, transcribe, or to a legacy service that you don't control, that you don't know how long it will take.
That's another really good example, yeah.
A human, I don't know, our baristas or our customers in Serverless Espresso when they're ordering.
That's right. We use it in Serverless Espresso, don't we? So when someone makes an order from their phone for a cup of coffee, the order starts, but it doesn't move on in the system until the barista actions it in some way. And so it's sitting in that workflow until the barista tells it, calls back to it by some means, right? And the way we do it here in this example is we emit our event onto the event bridge saying, okay, this is milestone 1, and you would route this event to some microservice that would handle milestone 1. And along with that event, you emit this unique task token, which is generated by step functions.
Yeah, you don't need to worry about that. That's something, soon as you put the right configuration, it will emit it for you.
That's right, yeah. And then you create a rule to route that task token somewhere. You probably need to store that somewhere, like a DynamoDB table. And then when milestone 1 is finished, it will grab the task token and call back to your workflow. And then the pattern continues, right? And your workflow will wait in this state. It will pause in this state until it hears back from the task token. And because standard workflows can run for up to 1 year, it can wait for up to 1 year, and you don't pay for the wait time because there's no state transition. So this is when the cost model of standard workflow starts to really make sense now, because you can have workloads that run for days, months, weeks, even a year without costing a lot because you're not making any state transition. So we're looking at it from the other side now, right?
Yeah, but that's the power of the step functions as well, to have this long-running process that before it was very painful to do and to orchestrate. Now you can see the state because this only runs once, so you can put, I don't know, any kind of bureaucratic process or loans or all these things that need a lot of manual approvals and legacy integrations. And you can know exactly in what step everything is, in what state, what is happening, and who is processing this. So
and of course, like, you might not want to wait for up to a year, and step functions has features for that as well. It has a timeout, it has a heartbeat that you can set, and you can catch that. So you can say, I only want to wait for 20 seconds, and if I don't hear back, we'll throw an error and we'll catch that error and we'll take some other escalation path.
That's what we do in Serverless Espresso. We have the 5-minute timeout. So when people start ordering their coffee and they start chatting with someone else, then if they take for more than 5 minutes, they need to request a token again.
Yeah, we have an even better one in Serverless Espresso, where if the barista takes longer than 15 minutes to make the order, so they don't go back to move the workflow on within 15 minutes, then we assume that that's because there's a problem or the shop's too busy or something's going on there, which means the barista hasn't managed to handle it. So what we do is we stop the ordering process from even being possible so they can catch up. Yeah. It's like just a different, it's not an error, but something's happening, we'll catch that and we'll react to it, which is what step functions has built in, right? This error catching mechanism.
Exactly. And that's totally built into the orchestration and to workflow. So
yeah. And so here we show how you can implement that in this example that we've been going through. So we'll cut out those 2 polling loops. And on the step before, so this time it's not step function, sorry, it's not event bridge. We haven't had to change our workflow. What we've done is we've added this .wait for task token syntax to the prior step, which is, in both cases, we're putting something onto an SQS queue. And so along with that message onto the SQS queue goes this unique task token, and we store that task token, and we use that task token to call back to the workflow when the asynchronous process is ready and where it's complete. And because of that, we've removed a whole bunch of state transitions, times however many times we're going around that loop, right? In my little example, we're just going around it once, okay? But probably that's not realistic if we were having to do this as a standard workflow. So now there's just 8 state transitions, which means we've got an overall cost of just 20 cents. So just by applying the wait for callback and this nested pattern, we've more than half the cost of our workflow, right? And it can still run for 1 year.
Exactly. But at the end of the day, the cost of the workflow is not only running the state machine. No, it's like there is other cost around this. You still need to pay for your Lambda functions, for your Dynamo invocations.
That's right. Yeah. So all we're talking about so far is your step functions, the orchestration cost, right? We're not getting into the actual cost of the overall workload, which is something to consider. So there's another example I can show you here. It's a really simple example where I have a workflow where I get an item from a DynamoDB table, I invoke a Lambda function, and I put an event onto EventBridge. And we can step through like where there'll be cost cost implications. So first of all, the get item, I'm using the action for DynamoDB here. That takes up read capacity units. There's costs associated with that, right? Then I have a state transition, so that's back to my step functions cost. Then I invoke Lambda, so we know that's based on the duration of the Lambda function and the memory configuration. There's a cost associated with that. Then I go back to my step functions cost with my state transition. Then I put an event onto EventBridge. So there's different things going on. There's different costs getting billed here. But there's, again, knowing the service, coming back to what we said earlier, understanding how you can use features to reduce or optimize for cost. What you can do with step functions is wherever possible, take out those little Lambda functions that are not doing compute, the ones that are just gluing services together, or maybe they're just transforming data or some simple manipulation, right? And the way you do that in step functions at the moment is you can use these things called intrinsics.
I use them everywhere.
Yeah. I think last year at reInvent last year, we introduced 14 new ones, and we're always reviewing what else is needed, right? I know there's plenty of things in the pipeline to make step functions capable of doing more things natively. But what we have already is you can manipulate arrays, you can move around JSON objects, there's stuff for encoding, decoding data, string operations. This was the most requested one until it was launched, which was just generating a unique ID. So before this intrinsic was launched, you would have to use a Lambda function with probably 3, 4, 5 lines of code. This one is using a library just to literally generate a unique string and then send that back to the workflow. Now you can just use states.uuid. It's exactly the same result. And you can just append that to the parameters of an existing step or an existing state. You don't have to create a new state for that.
When you are putting things into Dynamo and you want to make a new item, and you want to have the primary key to be unique, that's the way to go.
Exactly. Yeah. And why do that? Well, there's no cost of invoking Lambda. That's the first thing. But also there's less code to manage. There's less delay because there's no code start or there's no call out to another service. It's all built into step functions. So there's not
also
really
one thing that I notice when avoiding calling all these small Lambda functions is also like the account limits. If you have a lot of state machines running, like how the Lambdas might be taken out from your account limits for maybe other important things that you're using Lambda for.
Yeah.
So the cleaner you can have your account and the less amount of code you can put is always better. And you can nest them. I do sometimes 3-4 levels of nesting to build very interesting things.
Yeah, I can't remember how many deep it can go, but
10.
Is it 10 really?
Yeah.
Wow.
It becomes very hard to read. That's the main problem. But I usually do for composing, I don't know, S3 URIs or S3 names or things like that, where I take things from here and then split them and then take the piece and put it in here in this format. I do all kind of weird things, but
it's quite satisfying, isn't it, to get like a nice clean string of intrinsics? Yeah,
exactly. And now with the test event, it's good because you can build those intrinsics and test them right away.
So the test event does actually let you test your intrinsics as well, does it?
Yeah, it lets you do everything. So it's awesome.
Yeah, that's fantastic. I think that the test event is the biggest launch of step functions.
It's my favorite launch.
Yeah, me too. It's funny, it didn't get the same fanfare as some of the other cool stuff, but I think it's probably the thing I'll use most personally.
I don't know. I've been using it now to build all my demos for the other launches of the function.
Right, yeah.
So it's the base of everything.
Yeah.
So this is kind of everything, I think, a great summary on cost of step functions. So I think we can end this video here. But this is the first on 2 videos that Ben is showing me. So stay tuned for the second part where we are going to talk about advanced patterns. So Ben, I see you in a future video.
Thanks, Marcia.
Bye-bye.
Bye-bye.
This was the video for me today. I hope you like it. If you did, please give a big thumbs up. And if you like this interview, don't forget to subscribe, enable notifications, and all those things, because the second part of this interview is coming up next week, in where we are going to talk about advanced patterns in step functions, so you should not miss that one. And in here you can find all the playlists with all the videos related to step functions that have been coming out, and in here is the first episode of this playlist, just in case if you miss it out. And I see you in another episode of FooBar. Ciao, ciao!